So good afternoon, everybody. In the last lecture, we have started the chapter that is unregulated power supply. Did you getting my voice? Please reply. Did you getting my voice?
Yes.
Okay. In last lecture, we have studied the started the chapter that is a unregulated power supply. See, in day-to-day application, we have to be need of the power for the purpose of the working of the devices, right? So, see, in day-to-day life, we have to be use more the AC power, right? AC indicate that 230 volt, 50 hertz, and the 5 ampere rating, right? This should be used for the whole application, right? But in case of your industrial or the in case of your laboratory purpose, we have to be use of the DC supply, because see, DC indicate the direct current that should not be varying with respect to time, right? That should be required for the purpose of the laboratory work that we have seen in this chapter, right? We already started the concept of filter. See, if I we need of the filter, that we have seen a next slide. But now see, what is mean by the filter? See, whatever the output, see, we know that we have requirement of the DC, right? That DC is not available from the natural indicate that the whatever the voltage or current coming from UNC, that is a AC. So for the purpose of the no fluctuation, that's why we have to use the DC. So to requirement of DC, we have to be convert the AC voltage into the DC voltage, right? That's why we have to be need of the converter, AC to DC converter. That is nothing but a rectifier, right? So for the purpose of rectification, we use normally two types of rectifier. One is your half wave rectifier, other is your full wave rectifier, right? These are the two types of rectifier. See, efficiency of full wave rectifier is more than that of sophisticated application. We have to use the full wave type of the rectifier, right? This will be used. See, but whatever the output coming from your rectifier, either your half wave or full wave. See, half wave rectifier have the more number of noise, that is called as pulsating component. In case of your half wave rectifier, that's why half wave rectifier used for the small kids toys, etc. Application that should be used. But the sophisticated application, we have to use the full wave, either your bridge type or center type configuration, because whatever the noise or whatever the unwanted component in case of your rectifier is less compared to the half wave rectifier. See, so we have to be tell what do you mean by the pulsating component. See, when we have to be convert the AC to the DC, it is not a pure DC, so it contains some of the AC part, so that is called as pulsating DC. So when we have to be convert the AC to DC, we have use the device such as a rectifier, right? Rectifier is the device which should convert the AC voltage into the pulsating DC. Pulsating DC indicate that it has some of the part of the AC, right? So this is not desirable for the some of the application. Please switch off the mic. See, whatever the noise coming, there is unwanted signal coming with respect to your rectifier is not some cases acceptable. In that case, we have to be requirement of the filter devices. So filter indicate that filter is the device which should be filter out the AC component through the your whatever the voltage applied, right? This will be the thing with respect to your rectifier, right? नेट गेलं होतं. ओके,
स्क्रीन दिसत नाही.
हा तेच आता दिसती का? पा दिसती का? आता शेअर केलेली आहे.
नो सर,
अजून पण नाही. ओके, आता दिसते? प्लीज रिप्लाय. स्क्रीन दिसते? स्क्रीन दिसते की नाही?
नो सर.
आता स्क्रीन दिसते का? प्लीज टेल मी. स्क्रीन दिसते का आता?
Yes sir.
See, we have seen the concept of filter. In that case, See, when we have to be convert the AC voltage into the DC, that DC is not pure DC, it contains some of the pulsating component. That's why to remove that pulsating component, we have to use the methods such as filter. See, some of the application, sophisticated application, which doesn't need of the AC component, that is a undesirable component. So that's why we have to use the sophisticated devices such as filter in that case. So definition of filter is that filter is the device which should remove the unwanted components such as AC component from the DC component, that is a pulsating DC component from your output, right? So filter is the device which should remove the unwanted AC component and give the pure DC component, that is called as filter. That is the use of the filter for the purpose of our application. Okay, these are the revised part we have seen again. See, need of filter, we have seen the why we have to be need of the filter. See, rectifier, we know that rectifier is the device which should convert the AC voltage into the DC, but that DC is not pure DC, it is a pulsating DC. So pulsating, this is the diagram of the pulsating DC component. See, this is the rectifier output, it indicates that this output may be pulsating DC. See, this is the pulsating DC, means it have the sum of the AC component, so that should be applied to the filter circuit, right? That should be applied to the filter component. Filter circuit is the device. What it does, see, filter circuit is the device which should remove the unwanted component from your pulsating component, and it only passes the pure DC output with respect to your load. That is the actually block diagram of your filter. See, what it filter does, that should be explained by here. See, we have applied the ripple content. Ripple indicate that it contains some of the AC component which should be applied to the filter. Filter is the device which should remove that unwanted component, AC component, and it gives the pure DC output. That is the actually block diagram which shows that why we have to be need of the filter, right? So filter is used for the purpose of to remove only unwanted component which should not be needed for the our application, to give the pure DC power, right? So to give pure DC power, we have to be remove that unwanted component, and to remove that unwanted component, we have used the device such as filter is here. We have seen here. So unwanted AC component is also called a ripple, right? The name for the unwanted AC component is ripple. So ripple removing is requirement, because if it contains some of the AC part, see, any of the signal, if it contains AC component, that is not acceptable for the purpose of pure DC, so that it should be removed. Okay, now detailed diagram of filter, how it particular diagram of the filter. See, this is nothing but a 230 volt 50 hertz AC voltage is applied to the transformer. We know that transformer is the device which should convert the AC voltage into the AC voltage. See, AC into AC, right? So it is the device which should convert the AC voltage into the AC voltage, but that should be low to the high or high to the low. But it is a high to the low. That's why it is called a step down type of transformer, right? So whatever the voltage coming across here, consider as a 230 volt for the primary, and secondary there is a consider as a 12 volt, right? Came across your output, right? And there should not be any connection between your primary to the secondary. There should be connection between primary to secondary is a flux linkage, right? So accordingly, whatever the link, see, primary have considered as a more link, and in case of your secondary, there should be less link of the winding. That's why less voltage is generated across your secondary. See, whatever the voltage in case of your primary, in case of your secondary, that both cases that should be AC. So that should be applied across here. We know that AC indicate that it have two half cycle, that is a positive and negative half cycle. See, positive half cycle indicate that during first positive half cycle, see, plus is coming here, minus is coming here. So due to that plus coming, diode D1 is conducted, so that voltage is coming across here, consider as here. Again, minus, due to that minus voltage, diode, this diode is considered as a diode D3, it is not conducted. Now only diode D2. See, in this time diode D1, this is a diode D1, and this should be considered as a diode D2. So diode D2 conduct, because minus voltage is applied to the cathode of diode, so it should be conducted. So voltage is coming across here, that part and this part both are connected each other. So here and here voltage should be generated, right? So plus is coming across here, minus is coming across here. This should be happening due to the first positive half cycle. Plus is here, minus is here, right? So during second half cycle, whatever the voltage applied across it, that should be reversed because AC have 2 half cycle, right? So minus is coming across here, plus is coming across here. So minus voltage causes whatever the diode, see this diode is working, whatever the diode, this diode is already working, this is not working now. So reverse voltage is appear across it. So this is considered as a diode D3, and plus voltage is coming across here. So D4, D3, D4 is working. So same time, see, due to this positive voltage, positive is coming across here. Due to this minus voltage, minus is appear across here. So either your positive half cycle or negative half cycle, whatever the positive voltage or negative voltage coming across the point, that should be same seen here, right? So same positive voltage is appear across here, negative voltage is appear across here and here. So that voltage is applied across your capacitor and the inductor. We know that the function of capacitor is the device which should passes the AC signal, inductor is the device which should passes the DC signal, right? So that AC component, if it whatever the see whatever the voltage coming across here, if it contains some of the AC part, that should be directly going towards the below, that is a ground, and only see inductor is the device which should passes the DC signal. So that DC signal should be passed over here, right? Again, this is a capacitor. If it contains some of the AC component, if means if it remain, in that case that should be going towards the ground, and only pure DC is coming across your output. That's why this type of the filter configuration is called as pipe. See, CLC, it should be as like as, जर आपण असं पाहिलं नाही तिने तर पाय सारखं दिसतं, तर त्याला पाईप टाइप ऑफ फिल्टर असं म्हटलं जातं. ओके, तुम्हाला डिटेल डायग्राम ऑफ फिल्टरची यासाठी दाखवले की ऍक्च्युअली फिल्ट्रेशन कसं होतं, पुढे डिटेल आहेच आपल्याला. ओके, सी वी हॅव सीन द सेम थिंग. See, component used in a filter circuit. We have discussed which are the components which should be used for the filtration circuit. We know that for the filtration purposes, we have used the two types of the component, that is inductor and capacitor, right? The basic function of inductor is that it only passes the DC signal and block the AC signal. The function of the capacitor is that it only passes the AC signal and block the DC signal, right? So whatever the function of it, that should be used for the purpose of your filtration purposes, right? So when we have to be capacitor used, in that case, whatever the AC component coming with respect to your filter, that should be going towards the directly ground, right? If it contains some of the inductor, it passes the direct DC supply, right? These are the function for the purpose of your inductor and filter, capacitor. Now we have seen through the mathematical equation how the inductor and the capacitor used, or how will be the equation of particular case, or whatever the effect of it, means why it is used for the purpose of filtration, that we have seen in here. See, we have seen the components such as inductor, right? Inductors indicate that XL, right? XL indicate that inductive capacitor. This is a XL indicate that inductive reactance of the particular devices, right? So inductive reactance of the inductor in case of this circuit is XL equal to 2 pi FL, right? XL equal to 2 pi FL. But see, we have to be thinking the same with respect to DC as well as DC. See, when we have to be tell it as a DC, we know that DC doesn't have any frequency, right? Because that doesn't have the positive cycle